Hey you, how are you, seventh grade? Okay, so let's learn about mean absolute deviation. Ooh, that's a mouthful. Let's look at this example. So suppose that 10 people played a dartboard game and these were their points. Okay, so we have 54, 40, 69, 49, 73, 42, 35, 60, 51, and 57. Find the mean absolute deviation. To figure out what that means, let's just look at that phrase word by word. Okay, so the first word is mean. All right, and mean is the same thing as saying the average. Remember how we've been practicing finding the mean in the last couple of lessons? Okay, so another word for mean is average. Okay, and then look at this word absolute. Do you remember when we learned about absolute, that word? If you're talking about absolute value, you're right. We were talking about using the absolute value to find the distance between 2 points. Okay, so if I want to take a lower, let's usually to find the distance between 2 points, you'll take the greater number, right? So you'll take the greater number minus the lower number. Okay, and in this case is 1 minus 3, which is the same thing as 1 plus 3, which is 4. Okay, 4 units. This is the way that we can find distance by doing the greater number minus, do you guys see the minus sign here? Minus the lower number. Okay, but another way that we could do it is by using the absolute value. If I do the lower number, okay, and that's the absolute value sign, so the lower minus the greater, and I take the absolute value, that'll give us a distance, okay? Because, let me see, so it would be negative 3 minus 1, which would just be the absolute value of negative 4. And this means, hey, how far is negative 4 from 0? It's just 4, which is the distance. Remember, with distance, it can never be negative. That's why we use absolute value when we do a lower number minus the greater number, okay? And so in here, the absolute means distance, okay? It's related to distance. So I'm going to just draw an arrow, maybe not an equal sign, but it's related to the distance, okay? Now deviation, another word for deviation is change. So deviation can also mean change. Okay. All right. So mean is average, absolute relates to distance, deviation, another word is change. So average, distance, change. Okay. And when we talk about the mean absolute deviation, we actually focus on the first letters of each of these three words. M, A, D, like so. Okay, so MAD. Okay, so basically question A is asking you to find the MAD, which is mad. Okay. All right. Now that this information is in your head, I think we're ready to tackle this, okay? And we're going to do this example to help us understand how to find the mean absolute deviation. All right. So first things first is, let me just minimize my screen because I think I might cover up some items that will be shown, okay? We're going to find the mean score of the data, and you know how to find the mean score, it's the average. We're going to add up all these data values, and we're going to divide by the total number of units, which is 10, okay? And that'll become, eventually, 53. Okay, so that's the mean, all right? So to find the mean absolute deviation, your first step is to find the mean. Your second step, okay, find the distance or deviation of each value from the mean. So we're going to use a chart to keep us organized. So notice here I have 3 columns in my chart. First, I have my data item here, and you don't have to list it from lowest to highest, okay? You can just list it as you see it, all right? So this is not in any particular order, it's just in the order that they gave us in the data set. Now, the second column is the mean, and the mean, we figured out before, was 53. So it's 53 for all of these rows here, 53, 53, 53, 53. Next, we want to find the distance of data from the mean. So that means we're going to find, okay, this is the mean, this is the data. How far away is it? Oh, it's 1 unit away. So you can either do 54 minus 53, okay, or you could do, if you want to do, so you can do the greater number minus the lower number, okay? That's one way to find the distance of the data from the mean. So sometimes mean will be greater, sometimes the data item will be greater, okay? Or you can take the absolute value of the lower number minus the greater number, okay? Because that also gives us distance. Remember, distance can't be negative, okay? All right, so they did this all for us, and we can just check a couple of them. Like, for example, here, this data item is greater than the mean, so we can do 54 minus 53, which is 1, or we can do the absolute value of 53 minus 54, which is the absolute value of negative 1, which is equal to 1, okay? So you can do it either or, all right? And so they found this all for us, but we're not done yet, okay? All right, because we just found the deviation from the mean, okay? But we want to find now the sum of the distances, okay? Over here. So you're going to add all of this here in this third column here. Okay? And that'll equal 96. And then we're going to divide the sum by the number of data values over here. So then we know that there's 10 data values, right? Okay. And so we're going to do 96 divided by 10, which is 9.6. Okay? So basically, you're finding the mean of the distance of data from the mean. You're finding the average of the distance of data from the mean. That's what you're finding over here, okay? And what we're going to do now is we're going to figure out, what does the mean absolute deviation tell you about the data? Okay, well, the MAD is equal to 9.6, so what does that mean? Well, what that means is, on average, the data values are 9.6 units from the mean. So these data values are 9.6 units on average from the mean. It's not exactly 9.6 values, but on average, counting them as a whole, it is 9.6 units from the mean, okay? And so if you consider it, if this average over here, the MAD, was lower, okay, what does that mean? If this was lower than 9.6, it means it's getting closer, the data values are getting closer and closer to the mean. So that means a lot of the data is clustered closer around the mean than being further from it. If this MAD was, let's say, 20, okay, greater than 9.6, a lot greater, right? That means, oof, the data value is, a lot of the data values are spread farther away from the mean, okay? So that's what this MAD is about. I was going to say this is what MAD means, but I thought I was using the word mean too much. Okay. So, yeah, it's your turn now. So try your best, and luckily the steps are laid out for you, so just follow the steps, okay? And let's see what you get when you're ready. Hi again. All right, let's see. I think you're ready, okay? So we're going to find the mean score. So that means we're adding all of these values up and we're dividing by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that'll become 17. Okay, and so I put the mean in here, 17, in this column. All the data items are already in our chart for us. All we need to do now is find the distance between the data item and the mean. So let's see. Distance between this data item and the mean is 20 minus 17, which is 3. And then here, 16 and 17, the distance is 1. 13 and 17, the distance is 4. And so on like this. All right, so this is the distance between the data item and the mean. Now we're going to find the average of this, but to start to find the average of this third column, you need to first find the sum of this, right? So the sum of the distances is 34, and how many data values do we have? There's 10, so we're going to do 34 divided by 10, which is 3.4. And here, what does the mean absolute deviation tell you about the set of data? Well, maybe I can make this a tad bigger so you can see it. Okay. Then on average, the data values are, and then we're going to write our MAD value here, are 3.4 from the mean. Okay, and so that means on average, the score the students got on their quizzes are 3.4 points away from the mean. Is that a lot or a little? I guess it depends on how many points the quiz is, right? So let's say on average the data values are, let's pretend that it was just 1.2 from the mean. So that means, a lot of the data points are clustered around the mean, as opposed to if it was 3.4 from the mean. Let's say it was 9.4. Oof. That means if MAD was 9.4, then the data values would be further away from the mean than it would be if it was 3.4. But we know that it's 3.4. All right, so I hope you guys rocked that. If I went kind of fast, what you could do is you can replay the video again, and I think there might be an option for you to slow down the video if I'm talking too fast as well. And of course, we can always practice more on Thursdays, okay? All right, then I'll see you live on Thursday. Bye. Prepare some questions if you have any, and I'd be happy to take the time to go over it. Okay? Bye, everyone. Have a good day.